We are going to demonstrate how to perform the field density test. This test is performed in the field to determine the in-situ soil density. However, we need to determine the density of the standard sand in the laboratory before going to the field. This is a sand container which is full of standard sand. These are the sand cone and the calibration cylinder. First, we need to fill up the sand cone with standard sand and determine the mass of the standard sand inside the full sand cone. Handle the sand cone with great care such that it will not experience any shaking. Open the valve and let the sand to fall freely. Make sure that the valve is open completely such that no sand will be trapped in the orifice. After about 10 minutes, when the sand ceases falling and fills up the sand cone, we can close the valve. Compare the mass of the sand container before and after the sand is allowed to fall into the sand cone. There are some marks on the sand container. We can check the sand level. If the level doesn't change after 1 or 2 minutes, we can close the valve and weigh the sand container. Tilt the density apparatus, otherwise more sand may be falling if the valve is not closed tightly. Repeat this procedure for at least 3 times such that the measurements of the mass of the sand in the cone are within 3 to 5 grams. Then the average values of these measurements will become the mass of the standard sand in the cone. Now recycle the sand. Pour the sand into this calibration cylinder. Before the test, we should measure the inner diameter and the height of the calibration cylinder because we need to determine the volume. Put the base plates on top of the cylinder. They should align perfectly. Put the inverted sand cone and sand container on top. Then open the valve again. The sand will fall freely into the calibration cylinder and the sand cone. For example, suppose that the original mass of the sand container with the standard sand is 7,000 grams and the average mass of the sand in the sand cone is 1,000 grams. If the final mass of the sand container with the remaining sand is 2,000 grams, then the mass of the standard sand in the calibration cylinder will be equal to 4,000 grams. Since we have determined the volume of the calibration cylinder from its height and inner diameter, the density of the standard sand would be equal to the ratio of the mass of the standard sand in the calibration cylinder and the volume of the calibration cylinder. Once we know the density of the standard sand, we can bring the density apparatus to the field. Dig a hole at the designated sampling location at the site. The size of the hole depends on the largest grain size of the in-situ soil. Roughly speaking, the size of the hole is similar to this calibration cylinder. The hole can't be too big because the amount of sand in the sand container would not be enough to fill the hole. Once we know the mass of the standard sand that is required to fill the hole, we can back calculate the volume of the hole. As we know the mass of the in-situ soil that is removed from the hole, we can then evaluate the field density of the in-situ soil. Look at the sand level. It is dropping quickly because the sand is allowed to fall into the calibration cylinder. When this level ceases to change, measure the mass of the sand container and the remaining sand. Use the method that I just described to determine the density of the standard sand, then go to the field to find the density of the in-situ soil.